Okay, good morning, everyone. Do you have any questions about the homework? As usual, the way we start, you ask me a question about the homework, we go over it, and then we introduce the new material. Any questions about the homework? Put them on chat or just speak up. Okay. Right, so we're working with graph of function, and I'm going to keep working with the graph for a little bit today. So last time I gave you a graph and we analyzed it. Today we're going to do very similar, but the opposite. So suppose I tell you the following. Let f of x, so let f of x be a function. So it means that's a rule, it gives me an input. So let f of x be a function. And the table below shows some of its value. The table below show its value. What do I mean by that? Okay, means the following. I have a table, and instead of giving you a formula or a rule to talk about it, I have a table. So suppose I have 1, 2, 3, 4, 5. These are the values I have. And f of x, I'm going to put -2, 0, 4, 1, 6. Okay. So first, what do I mean by that? What does it mean, this function given by a table? It means here, those are f of x. It means x is the input, f of x the output. It means those are the input values, 1, 2, 3, 4, 5. And the output that corresponds to its input is given like this. I'm sending 1 to -2, 2 to 0, 3 to 4, 4 to 1, and 5 to 6. Okay, as simple as that. Okay, now the question is, sketch the graph of f. What do we mean by that? Sketch the graph of f. Okay, what does it mean to sketch the graph? It means sketch all the points that has for coordinate input, the output for this input. All the point input, output for this point. It means sketch all the points. Sketch the graph means all points. That's what the graph means. With coordinate whatever the input is, that's the first coordinate is the input. The second is the output that correspond to this input. As simple as that. So let's see, how do we do that? So we take, of course, two lines, a horizontal and a vertical lines. On the horizontal, we always put the input value. Okay. On the horizontal, always the input values. Always goes on the horizontal. On the vertical, we usually put, not usually, we put the output values. Okay, crucial. What are my input values in this problem? I gave a very simple problem. The input values are 1, 2, 3, 4, and 5. So right here, we're going to put 1, 2, 3, 4, 5. Always the input on the horizontal axis. And then, so these are my input values. What are the output? How I'm going to sketch the graph? I'm going to sketch the points that has for coordinate. 1, f at 1. 2, f of 2. So in this scenario, let's draw here a little bit table. In this scenario, the value at 1 is -2. The value at 2 is 0. The value at 3, 4, 1, and 5. So I'm going to sketch all those points. 1, -2, 2, 0. So 1, the output at 1 is -2. So this is my first point on the graph. So this is 1, the input. The output is f of -1, which is -2. So the second point is, the second point is 2, f of 2. F of 2 is 0. So that's my second point on the graph. The third point, f sent 3 to 4. So 3 is sent to 4. So 1, 2, 3, 4. That's my point. So this is 3, the input. The output is the value of f3, which is a 4. Then I keep going. 4, 1. So at 4, my output is 1. This is 1. This is my graph. That's what means sketching the graph. At 5, it's 6. So I have to draw, I'm a little bit off chart here, F, so it's 6, right there. So this is the point 4, I'm at 5, and 6, which is the output at 6. So sketching, so this is my graph. It's a bunch of points. Okay, so because my input consists only of 1, 2, 3, 4, 5, my graph is actually nothing more than a bunch of points given what we have. Okay, so sketching the graph is nothing more than sketching all the points that has for coordinate input and the value of the function at this given input. What matters is the input always on the horizontal axis. The output are on the vertical axis. Okay, so that's what means sketching the graph. All right, so with this in mind, on the worksheet that I gave you, we have, which are on bright space, we're gonna do one problem. I will put in front of you is also worksheet 1.3, which is on bright space. So you can either, and it's the last page, you can pull it out or you can try to read with me. Okay. So we're gonna work on 2 worksheets. I'm gonna finish 1.3 from last time, and we're gonna work on worksheet not 1.3 and 1.6, I guess. Right. So this is my problem. I want you to read it, and I'm gonna start asking you questions. Okay, so I read it. In the Andes mountain in Peru, the number of species of bats changes with the elevation above sea level. Let f be the function that assign to each height h measured in feet the number of species of bats at the elevation h. Question number 1 is, interpret the statement f of 250 equals 60 in terms of bat species and give unit to 250 and to 60. I give you a minute and then I will ask one of you, what do you think the answer should be? Okay, I want you to read the questions, analyze it, and then think about it. Please put your camera on for those who don't have it. All right, anybody ready or shall I pick? Okay, I'm gonna pick one student, Sierra Collier. Sierra, are you with me? All right. Xavier, Cody, are you with me?
Yes.
Yeah. Can you give me an idea? Interpret the statement. Give it your best shot.
250 equals the number of bat species, and 60 equals the height in feet.
Let's read the problem again. What does F do?
F is the function that assigns each height, h,
Yes.
measured in feet, to the number of species of bats
Okay, so
in
what is the input here? What does the F function do?
F is the height.
What do you give it? What does it spits back?
We give it 250.
Which is what? I don't want the foot number. I want the, what does the foot 50 represent? Forget about this line for a second. What do you give it? It is assigned to what?
The height.
The height. So what do you give it? You give it the height. What does it assign to it?
The number of bats.
The number of bats at this height. All right, so you input, so imagine like a machine. You input the height. It gives you how many bats at this height. Are you with me?
Yes.
Okay, so what is the input here? What is it you're giving the function?
250.
Right, so the 50 represent what?
250 represents the height.
Right, 250 represent the height.
Okay.
Are you with me?
Yes.
Yeah, 250 represent the height. You have to try to think about the function. Draw a little picture. What does the function? It assigns to height the number of species of bat. Okay, so the input here is the height. That's what goes inside. So the input is not 250. In general, the input is the height. And the output is the number of species of bat. Okay, so now I'm going to go back and answer the question. Can you answer the question now? What does the statement f of 250 equals 60 mean? Can you give it a better interpretation?
250 represents the height, and 60 represents the number of bat species at that height.
Exactly. Now we're focused. So f of 2, it means that the number of bat species, the number of species of bat at the height of 150, sorry, the height of 250 feet is 60. So if you are at the height of 250 feet, you can find 60 species of bat. Are you with me? Okay, so that's really the idea. So whenever you have a function, you have to analyze what is this function doing? What is giving me? What's the info is giving me? Now, part B is some values of the function f are given. Of course, the height changes. As the height changes, the number of species is actually changing with the height. So different height, we have different number of species of bat. And the table below is giving us some value of the function. Sketch the graph of f, label your axis clearly. All right. If I want to sketch the graph, it means I need to start with 2 lines perpendicular to each other. Okay. Now, of course, as I said, as the height changes, the number changes. What should go on the horizontal axis? Because I want you to, what?
Feet, the input.
Exactly. It means what in this problem?
Feet.
Height, right. So on the horizontal axis, always the input, it means the height in feet. Okay, and the height changes. As the height changes, the number. And on the vertical axis will go the output, which is the number of species of bat. And sketching the graph, it means sketching all the points with coordinate 0, f of 0, 50, f of 50. So first we're going to start like scaling. What's in the domain here? The domain are all the input values. So the input values are 0, 50, 100, 200, 250. That's what I am giving you. So we're going to kind of scale them down, and we're going to do it as a correct scale. So that's a 50 here, 100, that's the height, a height, and a height. So those are 50. So 50, 50, we're fine. Now, okay. The output are 180, 70, 65, 60. So how do you want me to scale this? If I do it every one, it's tedious. How do you want me to scale it? How do you want me to write numbers on the vertical axis? I mean, going by 10, going by 5, what do you want me to do?
You do 20s.
20s, okay, so I can do 20. So this is 20, 40, 60. So because we need some kind of scale, and I erased that, you guys who wrote it, because I should think, no, I'm gonna go lower, sorry. You guys don't have to do that, but I wasn't thinking clearly. So I'm gonna go 20, 40, 60, 80, 100, okay? 100. And now we're gonna, so of course, as I said, the height changed, the numbers change. So at 0, so at the height of 0, and we have 100 species. So I'm gonna start drawing, so that's my first point. Okay, now at the height of 50, I have 80. Means I draw the point 50, 80. That's my point right here. At the height of 100, I have 70. 70 is somewhere in between. So that's how we're drawing all the point. Input, that's 50. F of 50, which is 80 in this case. And then I keep going. At 200 is 65. If this is 50, 65 should be here. And then at 250, I am at 60, which is down here. Okay, so given the data, that's the type of graph that we have. Now, if we understand better the biology, I probably could have connected the dot, but since we don't have a good understanding of the biology, I will just stick to the number I gave you, and we have a bunch of points. Okay, so that's really the main idea. Always on the vertical, on the horizontal is the input, which is my height here, and on the vertical we put the output value, and then we have dots. We connect point if we understand the problem, and in this case we actually don't know what's really going in between, so we stick to that. Questions, please. All right. Now I want you to do the following problems. This again the worksheet for 1.3, I guess I called it, and 1.2 is also on bright space. And I'm going to want you to do the following problem. Again with graphing. And I'm going to give you a few minutes to interact with it. So let me explain. On the grid below, so I gave you a grid. Since yours is not printed, you can just make up your own grid. Sketch the graph of a function that has the following properties. Okay, so you guys want to sketch something but the function have to satisfy the following. The smallest number in the domain of f is -3. What does it mean, the smallest number? It means the smallest input value is -3. So that's the input value, it's -3 is the smallest. That's really what I mean by that. The largest number in the domain is the number 4. It means I want this to be the largest input value. So the graph is between -3 and 4. That's what I have in output. But okay, I want the function to take 1 to 0. At this stage, I stop drawing. It's up to you to do it. I want it to take -3 to 4. I want it to take -2 to 1. And I want the output at 3 to be less than the output at 1. And also I want every value between every value between -3 and 4 is in the domain. It means there is an output for it. It means I want you to connect the point. I don't want them to be just dot. All right, I give you again a little bit of time to think through that. And then I'm going to ask you, what did you guys do? Okay, I want you to graph, and I will pick one of you and ask you, okay, sketch a function that satisfies every one of those conditions. This, and that. Please, I like your camera on. Anybody ready?
Yeah.
Anybody?
Yeah.
Anybody like to say anything before I pick? Okay, I'm gonna pick one of you. Aiden, are you done?
For the f(1) equals 0,
Uh-huh.
go to 0 and just go to 0 and then go up 1.
So you're this one, f of 1 equals 0. Okay. What do you want me to do?
Go like the middle point 0. One sec. You'd go to the right one, you'd go to 1 on the horizontal,
Right.
and then you put the dot there.
Right, exactly. Remember, 1 is the input. So 1 is on the horizontal axis. Okay, I have 1 dot. Okay, the second one. Keep going.
Is that that's a -3, right? It's a little blurry.
Yeah, because I put this on it. Okay, that's 4.
So go up 4 on the vertical.
Very good. So we satisfied this condition. We satisfied that condition. Okay, keep going.
Is it a greater than or less than or equal to symbol?
No, we're doing this one. That's equal. Is this what?
It looked a little weird.
Okay.
Go to -2.
Uh-huh.
And go wait. Hold on 1 sec.
So it's the output at -2 is the same as the output at 1.
I'm not sure about that one.
What is the output at 1?
0.
0. So
Oh,
this
so
should,
0. Okay.
right. Yeah. So I am right here. With me? Everyone. Now, this property.
Well, if it's less than 0, it can be any of the negatives.
Any negative. So right here. Fine? Very good. Now, every value between -3 and 4 is in the domain. It means I need an output for every value between -3 and 4. So how do you want me to connect so that everything is between -3 and 4 will be part of the graph? Now connect them the way you want. So the idea now is to connect those dots. You can connect them by line anywhere you want, so that every value, because with this graph, -1 is not in the domain because I don't have an output for it. Now I want you to connect them, so everything would be between -3 and 4. Do you understand what I'm saying? Do you guys understand what I'm talking about? Yeah? So let's connect.
Yes.
Anyway, I don't care how you do it, honestly, as long as it's a function. So I can go up, down here, and then, I mean, it's up to you. You can go like that. That's one possibility. And then you can go like this and like that. Stop here. Okay? It doesn't matter how you actually connect them. That's one possibility. Okay, that's as I said. Now, every value between -3 and 4 is actually in the domain. The smallest is -3, the largest is 4, and every one of those conditions is satisfied. Every one.
When there's something like less than like f of 3 less than f of 1, wouldn't the dot on the graph be hollow rather than filled in?
No, because 3 is in the domain. They should be in output.
Okay.
Okay, they should be in output. Absolutely. Okay. When there is a hollow, with something I will talk about a little bit later on, it means that 3 is not in input value. So when there is here an open circle, that's what you're talking about. It means 3 is not in input. I mean, there is no output for 3, which is not what I want. I want everyone to be in output. Sorry, to be in input. Okay. Yeah. So this is what the graph is. Crucial to be able to do the graph, and your homework, especially the Moodle one, will have a graph in it. Now, the second part we're going to talk about is always the same ideas. Nothing really is changing so far, but so it's basically section 1.6, but 1.6 is what we are doing so far. So again, I have a function here, and I'm going to use this section basically to remind you the property of fractions. So I'm using this section to work with functions and to remind you all the properties of fractions. So I'm not teaching you fraction, definitely. I actually reviewing. So before I do number 2, you're gonna help me, and we're gonna review very quickly. So we're going to review properties of fraction. Okay. So basic property of fraction before I go back and apply them to the idea of functions. So what are the basic properties? First, think adding fractions, adding them. Adding fraction. If we have two fractions, like for example, 5/3 plus 7/3, okay, something like that. So here the denominator is the same. So you have 5 pieces, each one of them is a third. You add 7 pieces, each one is a third. So if the denominator is the same, you basically add the numerator. All right, so if you have the same denominator, the same, that's crucial. To add them, you basically add the numerator. So, and that's here crucial that we have same denominator. Because you're adding the same size pieces, 5/3 plus 7/3. Now, as you guys know, the minute I don't have the same denominator, or something like that, then I'm stuck. I'm not adding the same size pieces. Here, 5/3 plus 7/3 is 12/3. I know it's 4, believe me, but that's not my point here. The minute I don't have the same size pieces, this is 5/3, and then I'm adding 7/4, then as you know, we have to find a common denominator. Crucial. Okay, so in this case, we need a common denominator. Okay, now what's the common denominator here? Back to you. What's the common denominator? Common denominator is a number which is a multiple of 3 and a multiple of 4 at the same time. So what's the common denominator in this? 12. Because 12 is a multiple of 3. 12 is 3 times 4, and 4 is a multiple of 12 is a multiple of 4. So now common denominator, since I have a 3, to get to 12, I have to multiply by 4. So I have my equivalent fraction. 4, to get to 12, I multiply by 3. Now I have the same denominator, but I have to multiply up here by 3. Okay, that's how we do. So this will give me equal to 20 over 12 plus 21 over 12. Now I have common denominator. I haven't changed the value of my fraction, but the denominator is the same. So I have 20 pieces, each one 1 over 12, its size. 21 pieces, each one 1 over 12. So altogether I have 20 plus 21, which is 41 over 12. Okay, so if we have different denominator, if we have two fractions and the denominator is different, then we need to find common denominator. Common denominator, absolutely crucial, because we don't have the same size pieces. I cannot really add them. Okay. Now, part 3, multiplying fraction. Okay, so as I said, a quick review. How do you multiply fraction? All right. A simple scenario. Suppose I take 3, that's a number 3, times, let us say, 2/5. Okay, 3, just a number, not a fraction, times 2/5. This is what? Intuitively, this is what? This is 2/5 plus 2/5 plus 2/5. That's really what this is. So it means, of course, that's the same denominator. I can add, it's 2 plus 2 plus 2. So it's 3 2s times 5, which is going to give me 6/5. Okay, so multiplying fraction. First condition, if I have just a number, let me call it C times A over B. It's a C over A over B. So it means A over B plus A over B, it's you multiply the numerator divided by B. That's how it works. And that's really the reason for it. That's really the reason. So 2/5 plus 2/5 plus 2/5, it means you have 3 of them. Now, 2. If you multiply two fractions, suppose I tell you 3/7 times 2/5. Now, how do we multiply two fractions? Okay, we multiply the numerator, product of the numerator, over product of the denominator. So in general, if you have A over B, one fraction, you multiply it by another fraction. It's the product of the numerator over product of the denominator. Okay, crucial. Could you share your screen? Oh. Okay, thank you guys for helping each other. Good, all right? So this is how we multiply fractions. So whenever I have a fraction times a fraction, it's the product of the numerator over product of the denominator. Now, dividing fraction. Okay. Let us remember. I know that you guys, of course, you've seen this stuff, but it's just a review because when I use them, I want you to know them. Suppose we have this divided by that. Okay. How do we divide? It's 3 over 7. You multiply it by the reciprocal of that. 5 over 2. So division is this kind of multiplication. Now, how do we multiply fraction? We know that it's the product of the numerator over the product of the denominator, which is going to give me 15 over 14. Okay, so the rule for dividing them, fractions like this. A over B, if you divide it by C over D, so that's one fraction divided by another is equal to the fraction in the numerator, you multiplied it by the reciprocal of the denominator. That's a product now. Okay, that's a product. We know what to do with the product. All right, so those are basic operation on fraction. Okay, I'm waiting for you guys to just write them. Okay. So one more properties of fraction that actually it's nice to know. So power of fraction. What do I mean by power? Don't worry about the word. Okay, let's see what I mean by that. Suppose I take 2/5, that's a fraction, and I raise it to the power 3, for example. Okay, what do I get? What does this mean? Actually, let me start to the power 2, and then I take to power 3. It means 2/5 multiplied by 2/5. All right? Well, it's equal to what? Now, how do you multiply this? It's 2 times 2 over 5 times 5. Okay, so it's equal to, now I know it's 4, but I'm not going to write it 4. I'm going to write it's like 2 times 2, which is 2 squared over 5 squared. Okay, now suppose I take 2 over 5 to the power 3. Again, it's 2 over 5 times 2 over 5 times 2 over 5. Okay, so it's going to give me how much? 2 times 2 times 2, because it's a product, so you multiply the numerator, over 5 times 5 times 5. So it's going to be 2 to the power 3 over 5 to the power 3. So in general, if you have a fraction, A over B, and you raise it to any power, suppose I call the power n. So what n represents, it could be 2, it could be 3. So according to this, it's just like taking, it's basically A to the power n over B to the power n. So I rewrite it because I messed up here. To any power, is you take the numerator to this power over the denominator to this power. And that's the reason. I mean, if you ever forget the rule, it doesn't really matter. You just expand it the way I'm expanding it, and then you proceed. All right? Okay, so let me do a very, very small exercise with you just for adding fraction. Let us say I'm adding, what do I want? Suppose I take 2 over 15. And I'm going to add to it 5 over 6. Okay, very simple problem. So this is adding. And the denominator is different. Immediately, we need to find a common denominator. Immediately. That's in addition, different denominator, common denominator. All right. What's the common denominator in this problem?
It's
30.
What?
30.
30, absolutely. So it's actually what we look for, what we call, if you guys remember, the least common denominator. It means we're looking for a number that's a multiple of 15 and multiple of 6. So 15 is 5 times 3. 6 is 2 times 3. So the common denominator is the number that multiplies 15 and multiplies 6. So the common denominator is 30. Which is 5 times 3 times 2. Okay, so now let us just become what? 15. The common denominator is 30. To get to 30, I have to multiply this by 2. And to get to 30, this should be multiplied by 5. All right, And now the end of it. That's really, I'm safe now. That's it 30. That's it 4. That's it 30, and that's it 25. It's gonna give me 29 over 30, end of the problem. Okay. So this is my quick review of fraction. For those who have difficulties with that, please go over fraction and come to my office hours so I can help you with it. All right. With this in mind, any questions, please? And if I'm going fast, let me know. Okay. With this in mind, we're gonna do gonna go back to function, of course, because that's really what I am working with. And we're gonna try to do the following problem. You know, those problems are on right space, so they are in front of you. So here's my question. Let f of x equal x squared plus 3x minus 4. That's my function. It means I have a rule that you give it x, and that's my rule. Whatever you give it, it's gonna square it, add 3 times what you give it, and take away a 4. Okay? The graph of f is given. I am giving you the graph of f. It means, what am I giving you? I mean, how do we graph the function? Basic, when I get this thing, this parabola, how does the graph come up? Basically, you know that your calculator does it, but what does your calculator do? What your calculator do is basically make a table. That's really what the calculator does. And then they start taking input 0 and find the output. 1, find the, not 1, 0.5, find the output. 1, find the output. And they take dots, like what we did previously, and then connect them. So the way your calculator draw is verbatim what we're doing. They take hundreds of value of inputs, they find the output that correspond to them, and they end up with a bunch of dots, little dots, and then they connect the dot. That's how your calculator does it. They compute, they do all those computations, but they can do hundreds of them, not 2 of them. So this is the graph of the function. My question is part A. Find the missing coordinate of the point A. So I know that you don't see the point A. I'm going to write it here. That's my point A, right there. And my question is, find the missing coordinate. What's the missing coordinate? And B is the point right there. So I'll write it clearly. This is -2. The question is, find the missing coordinate. Now, I give you a minute, and then one of you will have to give me A. What's the missing? Remember, that's the graph of the function. It means every point here has for coordinate whatever the input is, which is right there, and the output, f of this input. That's what this every point here. Very, very specific point. All right. You need less than 1 minute to find the second coordinate of A. And I'm going to ask one of you. Carl, no, not Carl. C-A-E-L. Kyle, I think.
Mm-hmm.
Yeah.
Kale.
Kale.
What was the question?
What's the second coordinate of the point A? The point on the graph. This is
-4.
Because you're right. What did you get -4 from?
The original equation.
Right. So it is, be more precise. You're absolutely right. It's f of 0. Okay? So find the missing coordinate. This is a point on the graph. So if the first coordinate is 0, the second have to find f of 0. So here I find, what is f of 0? I plug in 0 into my output. I put 0 for input. 0 plus 0 minus 4. F of 0 is -4. So my point A, if this is 0, it's a point on the graph. It means its second coordinate has to be -4. That's what the graph is. Every point has 4 coordinates. The first is whatever I give you. The second is the output that correspond to this input. Now B. Esmeralda, can you give me B? Did you do it? So this
I
is
didn't do it because I didn't get it.
okay. What should be here? If this is -2, this is a point on the graph. It means what should be here? So this is -2. From here to here, what this should be? F, the output at -2. Okay, so what's the output at -2? F of -2 is equal to -2 squared. I'm plugging into the equation of the function plus.
Would it be
Theta.
-14?
What?
Sorry. I
Go
said,
ahead.
would it be -14?
I actually did not compute it. Let me try it. Let me check it with you. -2 squared is -2 times -2, that's a 4. 3 times minus that, it's a 6. -4. No, it's not 14. It's -6. Right? Because -2 squared is -2 times -2. Minus plus, so it's going to give me a 4, -6, -6. So the point B is the point, is a point on the graph. What does it mean? It means if its first component is -2, the second has to be the output at -2. So this means that the point B is -2, -6. Okay, so what characterizes point on the graph? Every point on the graph is whatever the first component is, the second is the output for this component. Okay, now B, C, and D. B, F of 2/5. F of 2/5. Now it's just practicing. What's F of 2/5? Okay, what am I supposed to do? Matthew? If I want to compute F of 2/5. So 2/5 should be somewhere in here. What's F of 2/5? What would you do?
I'm not really sure.
Okay, what does F do? Takes an input, it sends it to where? X squared plus 3x minus 4. Okay, so if I tell you F of 2/5, it means F sent 2/5 to where? If I put here 2/5, what will F do to it? It squared it plus 3 times 2/5 minus 4. That's what F does to anything you give it. So what's F of 2/5? It takes 2/5, it's squared, plus 3 times 2/5 minus 4. I stop. I stop right there. Does it make any sense to you? Please, if it doesn't, you have to let me know. It's crucial. I mean, I cannot move one word forward if you don't get that idea. All right, now the rest is fractions and algebra. It's equal to 2/5 to the power 2 is how much? Remember, I just tried to remind you, what's 2/5 to the power 2? It's 2/5. Go ahead. Right, over times 2/5. It means it's what? 2 times 2, it's a 4, over 5 times 5, 25. Correct? So 2/5 is 4 over 25 plus 3 times 2/5 is how much? Back to you. You can put on chat if you want. How much is 3 times 2/5?
6/5.
6/5. It's 2/5. If you ever forget, it's 2/5 plus 2/5 plus 2/5. That's really what it is. That's what 3 times it. It's how many fifths? It means I have 6 of them. Or you multiply 3 times 2. So I'm going to do that. It's 3 times 2 over 5 minus 4. Okay? So it's equal to. It's 4 over 25 plus 6 over 5 minus 4. Okay? Now, if I want to find a common denominator here, what would be a common denominator? Back to each one of you. Madison? What will be the common denominator? I'm going to add those. Those are fractions, but I can't add them. I need a common denominator. What do you think is a good common denominator?
5.
Are you sure? Look at it carefully. What do I have? I have.
Would it be 25 then?
Right. Why? Because I need, that's 25 here. That's 6 over 5 minus 4. The common denominator should be a multiple of all of them. If you tell me 5, 5 is not a multiple of 25. Okay, so the common denominator is 25. And now I'm going to write it equal to 4 over 25. This hasn't been touched because 25 is the common denominator. Plus 5, if the common denominator is 25, this has to be multiplied by 5. And the numerator by 5. Minus 4. 4 is basically 4 over 1. To have a common denominator of 25, I have to multiply the denominator by 25, and I multiply the numerator by 25. Okay, and this is equal to. Now I have 4 over 25 minus 30 over 25 minus 100 over 25. Okay, now my common denominator is that. So now I can combine the numerators. I will have 4 minus 30 minus 100. And now minus 30 minus 100, now I can use your calculator. That's give me minus 130. And I add 4, I will have minus 126 over 25. Okay.
Why did you switch the sign from addition to subtraction in the?
Where? Oh.
In the third step, yeah.
Oh.
Yeah.
Oh, because I did a mistake. Thank you very much.
Oh, okay.
Thank you very much. I have no idea why I did that. Thank you. That's going to give me minus 70. Minus 66. Thank you very much. Okay. Very good. Now, I have to stop here because I have to give you enough time for your quiz today, since it's the first time you're taking the quiz. Now, for next time, I'm going to assign, of course, homework, and the homework will be basically exactly this problem, and you should do it to get a good practice of it, all right? Now, for Moodle, a lot of you hadn't tried yet to get to Moodle. I gave you all the instruction, and by Thursday, I want all of you to try to register to Moodle so I can tell you exactly how it works. Okay, are you with me? So by Thursday, I want all of you to follow the instruction I gave you verbatim. Okay, and then to register in the Moodle and have access to it. And start, looking at the problems. And on Thursday, if all of you are there, I can guide you to tell you how to work with it. But I looked up last night, a lot of you did not try to log into Moodle. Please follow the instruction and log to Moodle verbatim. And today I will give you practice problems along the line that I'm doing now. And please do them for Thursday. Okay, now the quiz, how it's gonna work. Go to Brightspace, all of you. Go to Brightspace, I'll share the screen with you. Go to Brightspace. Where is my Brightspace? Right here, okay. Okay, that's Brightspace. Go to the content area. Are you all on the content area? Now, down, there is a module called Quizzes and Exams. Do you guys see it? All of you. Do you guys see it? Tell me yes or no.
Yes.
Very good.
Yeah.
Click on it. Did you click on it? You see
Yep.
quiz 1. You click on the quiz. You come here. The quiz is in front of you. Now, if you have a printer, print it. If you don't, it doesn't really matter. I want you to do those problems. It's only one page. Write very clearly. Write your answers on a nice piece of paper. Remember, I have to read this stuff. Once you're done, upload it into Brightspace. You can take a picture of it and then upload it into Brightspace. Get going.
Do you want it as a PDF file?
Yes, I would love it as a PDF because Brightspace work well with PDF. I don't
Okay.
want any picture from Apple. Those HEIC, Brightspace cannot read them and I have a problem with it. So PDF is the best way for me to read.